number, so that's not to say that this one was missed the most, but these are just overall what was missed the most in the practice test. On tomorrow's test, the majority of the systems that we solve algebraically, you have the choice, but there are a couple where you have to use substitution and you have to use elimination because the work is going to be graded. Now, with that being said, those are the one that's substitution is perfectly made for substitution. The one that's for elimination is perfectly made for it. So it isn't really hindering you at all. But on this practice test, I gave you the choice, right? So what would you say is the best method to use here? I would use elimination, and not only elimination, there's definitely one variable that's calling out to me saying, oh, eliminate me, eliminate me. Yeah, I would say the y's also. So if I'm going to eliminate the y's, I would multiply on the bottom by 4. Because that's going to give me matching coefficients, and they already have different signs. Right, Lily? Yeah. Are those your Halloween pants? What are you going to dress up as? You're going to be onesie woman? Like instead of Wonder Woman, you'll be onesie woman? Negative 268. Check my math. Right. Yeah. Where'd you get the 4? Well, because I need to make the coefficients match. So right now, the way that it was written originally, does the number in front of the x's match? No. Do the numbers in front of the y's match? No. So if I'm going to use elimination, which that's what we decided, because both equations are in standard form, I need to make them match. So if I want to get rid of the x's, they need to match at their least common multiple. Meaning if I count by 5s, 5, 10, 15, 25, 30, 35, 40, and count by 7s, like every time Colin scores a touchdown, 7, 14, 21, 28, 35, 42, 49, what would be the first number they have in common? What's the first number on the first list of numbers I gave you that was in common with the second set of numbers I gave you? Okay, let's try again. Yeah, I'll write them down for you. How about that? 5, 10, 15, 20, 25. Huh? No. 30, 35, 40, 45, 50, so on and so forth. 7, 14, 21, 28, 35, 42. I'm just adding 7 every time. What's the first one that's in common? 35. There's 35, there's a 35. So if the x's are going to match, it has to be at 35. So I would have to multiply each of those numbers by whatever it takes to make them a 35. Ugh, we don't like it. That's like this. I could if I wanted to, but I'm not going to. Because the y's from the beginning were saying, ooh, eliminate me, eliminate me. Because if I count by 2s and count by 8s, what's the first number they have in common? 8. It is an 8. And since the top already has an 8, notice how I left the top equation exactly as is. And then in order to make the bottom 2 into an 8, and this is great, I love the fact that they're different signs because I need them to also have different signs. That's why I multiplied the entire bottom equation by 4. Which I'm allowed to do because in any statement of equality, I can do whatever I want to one side as long as I do it to the other. Everything got multiplied by 4. Now you notice how the y's both have an 8 in front? One is positive and one is negative. So, pow! So then Emiliano knows that 28 plus 5 is 33x. Because we add. The reason why they cancel is because you added. Negative 29 minus 268 is negative 296. Negative 297. And you disagree?
Oh, yeah.
And then we'll just divide by 33. What's x equal to? Negative 9? You want to ask Emiliano to be sure? Emiliano, did you get negative 9?
No, he didn't get that. You want to double check then, Kiara, just to make sure? Because I want to make sure Emiliano agrees. 97 divided by 33? Yeah, it's negative 9. I'm just messing around. Now that I know that x is negative 9, I'd like to find y. Use any equation you want. I'll just use the top one. And I'll write 5, but instead of x, I'll write negative 9. Plus 8. Then the y I'm looking for is equal to negative 29. Negative 45 plus 8y is equal to negative 29 plus 45 plus 45. 8y is equal to 16. Divide by 8, divide by 8. So y is equal to 2. I don't know if this is a good thing or a bad thing, but an entire third of when you solve these, a third of the question, a third of the points. I have to go back and read how the teachers, algebra teachers agree on it, but like a third of it has to do with the setup. I think if you did like the first step right, then a third of the points come from like how you solve to make sure you didn't make a mistake there. Actually, no, you know what I think it is? I think a third of the points is the first variable. Did you get one variable right? And then a third of it is did you get a second variable? But then a whole third of the question is just going to be up. Do you know how to write it like an ordered pair? So you could go through everything, have everything perfect, and then if you put 2 negative 9, you lose a third of the points available to you. Because the ordered pair means like alphabetical order, so what should come first? Negative 9, 2. Any questions? Okay, here's the next one I was missed the most. These were all like 43% and less, something along those lines. Everything that's here. What would you say would be the best method here? I like elimination. Now, you can make the case for substitution if you wanted to use substitution. I would solve for one of these. Like, let's say you wanted to solve for the bottom y. I would just do minus x, and then y is equal to negative x minus 1, and then put that into the y on top. And I would. Substitution means you need to know the value of one variable, and you substitute that value into the other equation. You can make a very logical case for using substitution, but I'm going to go with Ann on this one, as we should always do. And I'm going to use elimination because both equations are in standard form. Lily? Yeah. If I want to get rid of the x's, they're clearly not the same coefficient right now, but what number would they be the same at? What number could I make them meet at? And be BFS forever. What is the least common multiple of 3 and 1? It is 3. If I want to make the y's match, what number would they match at? Well, it'd be 4. Okay, before the sign. The only thing about the signs that's going to make sure that they're different. And actually, not that you have to, because you can make the signs different if you want to, but since the y's already have different signs, I'm going to choose to eliminate those first. So let's go times 4. Times 4. So 3x minus 4y is equal to negative 24. Then 4x plus 4y is equal to negative 4. So I can cancel them. Add everywhere. 3 and 4 is 7x. That's equal to negative 28. Divided by 7. X is equal to negative 12. Now I can solve for y. I can use any equation I want. They'll both give me the same answer, but it's whatever equation you pick. Instead of an x, you ran a negative 4. I would assume most of you would prefer to use that one. Less stuff to do. So negative 4 plus y is equal to plus 4 plus 4. Lily, how would I write that as an ordered pair?
-4.
You write it the same way, Adam? Emiliano. Hey, just pretend, man. I know it's really boring, but just take the hoodie off and pretend. Thanks, man. Appreciate it. Strangely enough, this was one of the ones missed the most. Lily, why shouldn't, now that you understand the elimination a little bit better, Lily, why should this one not be one of the ones missed the most? Colin, that's not why I put them back there.
There's 2 and 4 for the Y.
Yeah, the Y's already match and they have different signs. So I can just add and get 6x is equal to 12, divided by 6, and in about 10 seconds maybe, I know that x is 2. Now that I know that x is 2, I need to find y. Pick any equation you want. I'm guessing most of you probably pick that one and say that 2 minus 4y is equal to 14. Minus 2 minus 2. Negative 4y is equal to 12. Divided by negative 4. So y is negative 3. Can Kai write that for me as an ordered pair? I, Sam, I am. You like that as much as you like green eggs and ham? No questions? This one was also one of the ones missed the most. Strangely enough. Colin, I saw that look, so what method would you want to use here? I would also use substitution. Substitution just says, hey, if you got one variable already solved for, plug that value into the other equation. But here, I have 2 variables solved for, so let's just pick. Either get this x plus 6 and put it in for the bottom y, or get this 2x and put it in for the top y. Regardless of which one you pick, you're going to end up with 2x is equal to x plus 6. Each time you substitute, whether it's at the beginning because you're doing substitution, whether it's at the end when you use elimination, but each time you substitute, how does your equation look different than the equations before? What's different about the equations in red than the ones in black? Yeah, good. If you substitute properly, you should only see one variable, so that's what allows me to solve for it. Minus x, so x equals 6. Lily, what's 6 plus 6?
12.
What's 2 times 6? Still 12. So look at that. That just perfectly goes to prove that if you solve correctly for the first one, you should be able to plug it into either equation, and it makes no difference because you're going to get the same thing. Georgiana, how would I write that as an ordered pair? And why? Because that's the order that you solve for it. You got the 6 first, so you write the 6 first. Why? X and then Y. How about if it wasn't X's and Y's? How about if it was A's and B's? What would you write first? But how about if it was like M's and N's? Which one would you write first? Alphabetical order. Okay, strangely enough, also one of the ones missed the most. Why shouldn't this have been, Lily?
Because
the x's have matching coefficients and different signs, so they're ready to be eliminated. So I'll get negative 2y is equal to 18. have a -2. So 1 equals negative. Now you can plug that back into either equation that you want. I guess I'll just part one. So 3x minus 4 times negative 9 is equal to 9. I just got this negative 9 and I plugged it in. Yes.
When I get home, where you said, I mean, not the
You were here yesterday, right? Yeah, so it's already available now. Like, so you could take it anytime tonight, anytime tomorrow, up until 11:59 tomorrow. Unlike yesterday, when you do the retake, it's gonna tell you right away what score you got, what percent. You'd have to divide. It's gonna tell you how many you got right, and it's gonna tell you how many total points you do. You just have to do the division to get the percent. It'll also tell you the ones you got wrong. I have it set up to not. It won't give you the right answers because that would defeat the purpose. But it will tell you which ones you got right and wrong. And then if you want to use your second, you can do it 2 times. But if you do it a 3rd time, then I'm not going to count those, and the grade you would stay with is the one you got yesterday. When you substitute, how many variables do you see? Just one. So 3x plus 36 is equal to 9, minus 36 minus 36. 3x is equal to negative 27 divided by 3. Martha is happy because x is equal to 9. So now Georgiana, oh, well, never mind. What's the order pair going to be? Yeah, they're both -9, but what I want to make sure you understand that it's not because that's the order I solved it, because x has to come first. This -9 is technically bigger than this one. You're not trying to make weight for wrestling? No. Are you wrestling? I thought I saw you yesterday at wrestling. Jair wants to wrestle too? But you would finally have an excuse to wear all that spandex that you have in your closet and stuff. You can wear all the tights. Oh well. All right, so okay, this one I can kind of see why maybe this one would have been one of the ones missed most. Because this one I would definitely I cannot see a way, Adam, where you would want to use substitution. I think in any type of scenario, if you were to try to use substitution here, you'd have to work with variables. Not variables. Well, you would encounter fractions. Sorry, and we don't want to deal with fractions. And with elimination, there's really no variable that's like perfect to eliminate. You're gonna kind of have to manufacture it. So, Lily, if you want to get rid of the x's, what number would they meet at? What's the least common multiple? 40. Good. If you wanted to get rid of the y's, which number would they meet at?
42.
Good. So since we never get to hear from Shiobi, we'll let her decide. Shiobi, do you want to get rid of the x's or the y's? Okay, so if you want to get rid of the x's, Lily was correct. She said make them meet at 40. So I have to multiply the top times 8 and the bottom times 5. But Lily, if I only do that, yes, I'm gonna get 40s in front of both of the x's, but the signs are gonna still be both positive. And I don't want that. I want one of them to be negative. So pick one of the two. It doesn't matter. I tend to pick the bottom one, but that's just whatever preference. It's not a have to. And I'll make one of them negative. I'll make the 5 negative. Then we multiply 40x plus 56y is equal to 256. And negative 40x minus 30y is equal to negative 230. Check my math if you have a calculator out, please. Poor Flavor. Brandon, how dare you? Wakey, wakey. to this in Brandon Hall, he was full of life. He was pushing around his friend, but then he comes to math and now he gets bored. That's just a show of affection. He wanted to put his head on your shoulder, but he was sitting down, so he couldn't. If you add 56 and negative 30 is 26y, and then this gives you 26, and then hip hop parade. Y is 1. Now that we know that y is 1, pick any equation you want. I'll just pick the top one. That's how I roll. And I'll say 5 times the x I'm looking for plus 7 times 1 is equal to 32. I just use the top one. Now that I substituted, how many variables do you see? Just one. So 5x plus 7 is equal to 32 minus 7 minus 7. 5x is equal to 25 divided by 5. X is equal to 5. Georgiana, how would I write this as an ordered pair? Good. Take that ordered pair. What are you counting? Of the year? There's 12. What's the thing that they teach you, like, for to remember which one has 31 days? You put like your knuckles together or something like that, and it's supposed to. It's something with your knuckles, and then like. Okay, you use these and you put them like that. So January is the first one, that's 31. Not February. March has 31, not April. May has 31, not June, but then July 31. August has 31. September has 30. October 31. November 30. Oh, but then I have an extra knuckle. I didn't get to use my extra knuckle. You learn something new every day? All right, here's another one. This was also missed quite a bit. Lily, what's good and what's bad about this? Let's dissect this.
So they're the same symbol.
What's the same symbol sign thing? Close enough, Jada? Well, see, the first thing I see is that I see that both of the y's have a 2 in front. So that's good. They have matching coefficients. What's bad is that the signs don't match. So what you should do is get one of the equations. I'd probably pick the bottom one, but it doesn't matter. And just get everything to multiply it by -1, because that's going to change the signs. But to be perfectly honest, since the climate that we exist in today, it isn't so much anymore about, teaching the right way to do things, Lily. It's more just about getting the right answer and getting the right answer and getting the right answer. So, yeah, if you can remember to multiply by -1, great. But at the very least, at the bare minimum, if you can understand, hey, look, what I need to do is change the sign, and then just remember to change all the signs, so make this positive and make that positive, fine, even that will work. So, Lily, don't complain later on when you make mistakes. And you end up being grounded for the rest of your life. So x is equal to 1. Now I plug that in, so 1 minus 2y is equal to -5. Minus 1 minus 1. -2y is equal to -6. Negative by -2. So y is, as an ordered pair, that is 1, 3. you were saying that it matches the sweater. It kind of does. Emiliano, you want to do the next one? You can get it started if you want. Good job, Emiliano. That's the spirit. He's dreaming that he's the little engine that could. He's going up the hill and saying, I think I can, I think I can, I think I can. Chugga, 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 chugga.
Probably systems of equations. All right, you're gonna want to pay attention to this because this is going to help you directly with one of the questions tomorrow. So you had this that said how many solutions. You will have at least one question on tomorrow's test, Adam, that asks you how many solutions. Just so that you understand the nature by which, because I kind of had a little bit of a problem with the wording of it, but that's fine. We're taking care of this now. The way that this question was intended was to be done the way that, remember when we first introduced systems, that we did graphing? How did we learn to determine how many solutions when we did graphing? What would we look at on the equations to determine how many solutions they were going to have? Okay. Jada? And? Good. So really, that's the way it's intended. But I will show you one other thing that I will accept. I don't think other teachers are going to accept it, but I'll take one other thing too, because we also went over that in class. Anyway, so the way it's intended to be is you're supposed to split these when they ask you how many. I don't know how you did it on this particular practice test, but so you just write them separately and then you put them in slope-intercept form. If you're going to compare slopes and y-intercepts, put them in slope-intercept form. Minus x. So that negative 2y is equal to negative x plus 6. Divide by negative 2. Cancels. Y is equal to negative 1 divided by negative 2 is positive 1 over 2. The x just drops to the side. 6 divided by negative 2 is negative 3. On the next one, minus 3x, cancels. Negative 6y is equal to negative 3x plus 18. Divide by negative 6, divide by negative 6. Y is equal to negative 3 divided by negative 6 is also positive 1/2. Keep the x on the side. 18 divided by negative 6 is negative. I just did the pretzel. Divide each one by negative 6. I did the same thing over here. So now when you compare and contrast, who can tell me how many solutions it's going to have on y? Go ahead, Ann. Infinite, it will have infinite solutions on y, Ann. Yeah, they got the same slope and y. Tomorrow's test will ask you to justify. So when you say infinite solutions, you will also, if you're going to use this method, you have to say same slope, same y-intercepts, if that were to be the case, if it were to be infinite solutions. But I will also allow one more method. So if you want to, because we talked about this in class, that's why I'm going to allow it. We talked about how to show this algebraically, where by step 3 we could figure out how many solutions. If I try to solve this algebraically and I can solve for either one, x or y, how many solutions do there have to be? One solution. And then you could stop there, you wouldn't have to solve for the other one. If there were going to be no solution or infinite solutions, all the variables would cancel out. So I can just copy and paste this. So if you wanted to do it algebraically, Lily, what method would you use?
Standard.
That's not a method.
Wait, what was it?
Go ahead, Colin. No, I'm gonna do this algebraically. Yeah, I'm gonna use elimination.
Elimination.
Yeah, I'm gonna.
this is the way that the question was intended for the tomorrow's test. And I really prefer, if you know how to do this, I just prefer you do it this way. Solve for each y. I'm perfectly fine with it. But I also care that you get it right. And since we went over it, I feel we have a right to do it this way. So if you were to do it algebraically, I'm going to eliminate one of the two. Let's eliminate, let's do the x's here. Let's get crazy. And if I were to get rid of the x's, I have to multiply the top by -3. So I get -3x plus 6y is equal to -18. On the bottom, I get 3x minus 6y is equal to 18. So remember, I said I was going to eliminate the x's. But when I go to add the other columns, everything eliminates. Well, since the variables are gone, I don't care so much about the other side where the constants are, but since the variables are gone, that means I cannot have one solution. Now, depending on what's left over, I'm either going to have all solutions or no solutions. We already know that this one's going to be infinite because we already checked it, but what's left on the left side? What's left on the right side? So that would be the work, and then the reason, the way that you justify is you would say, because this is an identity. When you have two equal sides and no variable, that's called an identity. Another I word, like let's say this would have been no solution. Let's say you get a 0 on the left, but then like a 15 on the right. If you get two numbers that are not equal, the word for that is inconsistent. The equations are inconsistent. Up to you how you want to do it. Any questions there? All right. So then that's it for the review from the practice test, Martha. So what I'll do for the rest of